Good morning, students. Today I will discuss different micro operation and design of the arithmetic and logic unit. Now there are several micro operation available. Arithmetic logic. Now micro operation and design of arithmetic logic unit. Now arithmetic logic unit is the main part of the central processing unit, and it is process the instruction. Now the other parts of the CPU are the control unit and register unit, and ALU simply executes the instruction in order as dictated by the control unit. Now the ALU performs the instruction execution on the operand data which is stored in the register. Okay. Now a CPU with many registers reduces the number of references to the main memory. Okay. Now and thus simplify the programming task and shortening the execution time also. Now what do you mean by a micro operation? Now an operation performed on the data that is stored in the register is called the micro operation. Okay. Now the result of the micro operation may also replace the previous binary information of a register or may be transferred to the another register also. Now example of micro operation are add, subtract, shift, load and clear, etc. Now there are frequently used micro operation which is available in the digital computer are classified into 4 categories. Now what are they? Now number 1 is a register transfer micro operation. Transfer a binary operation from one register to the another register. Now second one is the arithmetic micro operation. Now arithmetic operation performed on the data that is stored in the register. Now another micro operation which is available, that is logic micro operation, specify binary operations for string of bits which are stored in the registers. Now next micro operation is the shift micro operation. Shift operation are used for serial transfer of the data. Now today I will discuss how the 4-bit arithmetic circuit can be implemented. Okay. Now first of all I will show you the diagram. Now here 4-bit arithmetic circuit is implemented using 4 1-bit full adder. Okay. And here also 4:1 multiplexer is needed here. Okay. Now here in every 1-bit full adder, you can see there a value is entered into the X input. Now A0, that is least significant bit value, is entered to the X0 input. A1 entered to the X1 input of the full adder. A2 entered to the X2 input of the full adder. A3 entered to the X3 input of the full adder. Okay. Now the B input, it is not directly applied to the full adder. How it is applied to the full adder? Now B input is passed through the multiplexer unit. Now B0 value is entered to the multiplexer 4:1 multiplexer first input, 0th input. B1 entered to the 4:1 multiplexer 0th input. B2 entered to the 4:1 multiplexer 0th input, and B3 entered to the 4:1 multiplexer 0th input. Okay. And B0 complement value is entered to the second input of the multiplexer. B1 complement is second input of the 4:1 multiplexer. B2 is entered to the second input of the 4:1 multiplexer. B3 is entered to the second input of the 4:1 multiplexer. And here in the third input of the multiplexer, there are logic 0 value is connected. Third input of the every multiplexer, logic 0 is applied there. And in the fourth input of the multiplexer, logic 1 is connected. And here also in the first full adder, as there we use to decide 4-bit arithmetic circuit, we have used here total 4 1-bit full adder. And in the first full adder stage, Cin input is applied there. Cin initially applied here. Okay. Now, total using this circuit diagram, several 8 operation can be possible. Now, what are they? Now, depending upon the value of S1 and S0 and Cin input, different 8 operation can be possible. Now, depending upon the S1 and S0, 0, 0 and Cin equal to 0, addition operation is possible. And depending upon the value of S1 is 0, 0, 0 and when the value of Cin equal to 1, addition with carry operation is possible here. Now again see the circuit diagram here. So now when S1 and S0, 0, 0 value and Cin equal to 0, that time what happened? Every 4:1 multiplexer select the normal input B0 and that B0 input will direct to the output of the first multiplexer, and similarly from the second multiplexer B1 input will be selected and that will direct to the output of the multiplexer. When S1 S0 equal to 0, 0, that time B2 input will be direct to the output of the multiplexer, and when S1 S0 0, 0, B3 input will be direct to the output of the multiplexer. So in this way, what happened? Full adder takes in the Y0, Y1, Y2, Y3 input the value that is normal value of B, that is B0 from here B1, from here B2, from here B3. Okay, and if the value of Cin equal to 0, what happened? Here addition operation, simple addition operation will be possible. Cin 0. Okay, A plus B operation will be possible here. Now when the value of Cin equal to 1, in that time what happened? Addition with carry operation will be possible. So now next, S1 S0 0 1 and as well as Cin value equal to 0, that moment this operation is possible, that is A plus B bar, that is subtract with borrow operation will be possible. And when S1 S0 0 1, Cin equal to 1, okay, and that moment A plus B bar plus 1 subtraction operation will be possible. Now how it is possible? Now I will show you the diagram. Now S1 S0 0 1, that case what happened? From the among all the 4 input, second input will be getting selected, and here B0 is passed through the NOT gate. NOT gate output is nothing but B0 complement. So from here B0 will be selected, B0 complement will be selected, and that will be direct to the output. Now S1 S0 0 1, that time what happened? The second multiplexer will select the second data input, that is B1 complement, and that will direct to the output line. S1 S0 0 1, that time what happens? B2 complement will be selected and that will direct to the output line, and so on. S1 S0 0 1, B3 complement will be applied here and that will direct to the output line, and And in this way, what happened? Every full adder second input get the complementary value. That is, B0 complement will be applied here, B1 complement will be applied here, B2 complement will be applied here, B3 complement will be applied here. And when Cin equal to 0, that time subtraction with borrow operation will be possible. And when Cin value, initial carry value equal to 1, that time what happened? The subtraction operation will be possible. Because here what happened? We are just adding A value with the value of B complement plus 1. Now A plus B complement plus 1 means nothing but A minus B. That operation will be possible here. Now next. So now S1, S0 value 1, 0. In that case, suppose Cin equal to 0. In that case, D equal to A, that is transfer of A operation will be possible. That means whatever data is applied to the A input, that data will direct to the output. Now how it is possible? Now S1, S0, 1, 0, that time what happened? Multiplexer, all the multiplexer will select the third data. Third data is nothing but here logic 0 is applied to the third data input and multiplexer will select the third data input and this data, that is logic 0, will be applied here to the every Y0 input, Y1 input, Y2 input and Y3 input. So here if Cin equal to also 0, what happened? That time A plus 0, this operation will be possible. A plus 0, that means at the output we get D0, D1, D2, D3. See out we get the value of simple A. So here only the data transfer operation will be possible. So now if Cin equal to 1, that time what happened? So in that case, increment operation will be possible. The value of A will be added with the value of 1 only. So we getting the micro operation, that is A plus 1 will be calculated and that will be delivered to the output. Last case, S1, S0, 1, 1 and Cin value equal to 0. S1, S0, 1, 1 and Cin value equal to 0. In that time what happened? A minus 1 operation will be performed. That is, decrement of A operation will be possible. Now how the decrement operation will be possible here? Now S1, S0 value when it is 1, 1. So all the multiplexers select the fourth data input, that is logic 1 value will be selected and logic 1 value will be direct to the output line, that is Y0. Here logic 1 will be applied, Y1 logic 1 will be applied, Y2 also logic 1 will be applied, Y3 also logic 1 will be applied here. Now here in the every full adder from X0 it gets the value of A0, A1, A2, A3, but from the Y0 input, Y0, Y1, Y2, Y3 input, it will get the value logic 1, 1, 1, 1. Now here decrement operation is possible. Now how? of 0, that is 0001. If we want to find out its 2's complement, that is 41. Now a plus 2's complement of 1, that is nothing but a minus 1 operation will be possible here. A minus 1. And when C in value is equal to 1 also, in that time what happened? A minus 1 plus 1, that is A. That means simple data transfer operation will be possible. Now in this way, several 8 operations can be performed using this 4-bit arithmetic unit.